Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
And today we're looking at a paper that feels like it's straight out of a sci-fi thriller. It's about teaching AI to do something it's explicitly been told not to do, write malicious software.
Right, we all know large language models, or LLMs. The AI behind tools like ChatGPT are incredibly powerful. They can write essays, poetry, and crucially, they can write computer code. This has made programming accessible to way more people.
But with great power comes great responsibility and great potential for misuse. The companies that build these AIs are very aware of this. They've built in safety guardrails to stop people from, for example, just asking the AI, hey, can you write me a computer virus?
If you try that, the AI will politely and sometimes not so politely refuse. It'll say something like, I cannot help with that request. These safety systems are called alignment mechanisms, and their job is to make sure the AI stays on the straight and narrow.
But this new paper, titled MGC, a compiler framework exploiting compositional blindness and aligned LLMs for malware generation, reveals a massive blind spot in these defenses.
Okay, compositional blindness sounds very technical. Let's break that down.
It's actually a pretty simple concept when you explain it with an analogy. Imagine you want to bake a poisonous cake. If you go to a master chef and ask, can you bake me a poisonous cake? They're going to say no and probably call the police.
Makes sense. That's the AI's safety filter kicking in.
Exactly. But what if you don't ask for the whole cake? What if you ask for the individual ingredients, one by one? You ask the chef for a bag of flour, then you ask for some sugar, then some eggs. Each of these requests is perfectly innocent. The chef has no reason to refuse.
And then you go home and mix in your own secret malicious ingredient. The chef never knew what you were planning to do with all those harmless components.
That's precisely what compositional blindness is. The AI safety systems look at each prompt, each request in isolation. They are blind to the overall composition, the bigger picture of what the user is trying to build.
So when it comes to malware, instead of asking for a ransomware program, an attacker could ask for separate, benign-sounding bits of code.
Yes, for instance, write a piece of code that can find all the text files on a computer. Harmless. Now write a piece of code that can encrypt a file. Also harmless. It's a standard security function. Now write a piece of code that can display a message on the screen. Totally innocuous.
But if you combine those three pieces of code, you have the basic building blocks of ransomware. That's pretty scary.
It is, and the researchers behind this paper didn't just theorize about this. They built a system to automate the entire process. They call it the Malware Generation Compiler, or MGC.
A compiler is a program that translates human-readable code into something a computer can execute. So this MGC is basically a translator that turns a malicious idea into functional malicious code. How does it work?
This is the really clever part. The MGC system uses a 2-AI system. Think of it like a criminal duo, a mastermind and the muscle.
Okay, I'm intrigued. Who is the mastermind?
The mastermind is a weaker, less aligned LLM. It's not one of the big, super powerful models. It's not great at writing complex code, but its safety filters are a bit more relaxed. Its job is to take the high-level malicious goal, like create a virus, and break it down into a detailed step-by-step plan of all the innocent-looking functions needed.
So it creates the recipe for the poisonous cake. It figures out that you need flour, sugar, and eggs.
Exactly. Then comes the muscle. For this role, the MGC uses a very powerful, strongly aligned LLM like GPT-4 or Claude. These AIs are brilliant coders, but they are also heavily guarded by safety rules.
So how do they get the muscle to do the dirty work?
The MGC system feeds the innocent-sounding tasks from the mastermind's plan to the powerful AI one by one. The powerful AI sees a request like, write a function to find all files and says, sure, I can do that. Here's some perfectly written, high-quality code for you. It does this for every single benign step because it's blind to the overall malicious plan.
And once it has all these perfectly coded, innocent-looking parts,
the MGC framework assembles them offline, stitching them together to create the final, fully functional malware. The powerful AI that wrote 99% of the code has no idea what it just created.
That is a deeply clever and unsettling hack. How effective was it?
Incredibly effective. The paper shows that MGC is far more successful at creating malware than other methods like jailbreaking, which is just trying to trick an AI with a cleverly worded prompt. It even outperformed paid malware generation services found on underground forums.
Wow, so it's not just a theoretical attack.
Not at all. The code it produced wasn't just functional. In some cases, it was more sophisticated than real-world malware samples they tested against. The MGC could add extra features to make the malware harder to detect or remove.
Now, we should probably clarify that the researchers here are the good guys. They're security researchers, and this type of work is called red teaming, where you act like an attacker to find vulnerabilities so they can be fixed.
Absolutely. They're not releasing a tool for criminals. They're sounding an alarm for the AI industry. They've proven that this compositional blindness is a fundamental flaw in how AI safety is currently designed.
So what's the solution?
Well, it's not easy. The paper suggests that AI safety systems need to become composition aware. They need to look beyond single prompts and understand the user's intent across a whole series of requests. They need to be able to connect the dots between the request for flour, the sugar, and the eggs to see that someone might be trying to bake a dangerous cake.
Which is a much harder problem to solve. You're talking about the AI having a memory of the conversation and inferring a hidden long-term goal.
Exactly. It's a huge challenge, but this paper makes it clear that it's a necessary one. As long as AI safety features have this compositional blind spot, they'll be vulnerable to this kind of disassembly-reassembly attack.
A fascinating, if slightly terrifying look into the cat and mouse game of AI safety. It shows that just putting a simple do not do this rule on an AI isn't enough when attackers can get so creative.
It really highlights that securing AI is not just about blocking a list of bad words or requests, but about trying to understand true intent, which is one of the hardest things to do.
That's all the time we have for today. Thanks for tuning in to Daily Papers.